I've had a little more time to think about this since I'm towards the end of the line. I think that the simulations of the Colorado flood that we presented could be done with current technology in about 4 days after the reanalysis became available. Reanalysis takes about a month or more after a given day, so maybe one would substitute that with, say, a forecast result. And you'd need a team of maybe 7 or 8 people, of which at least half are technology folks, to help do with the data. You'd need a day to set up the run, a day or two to make the ensemble, and at least another day to post-process. But that's not the limiting factor. In our study, it took us longer to make the runs, but it took us way longer to figure out what was going on. We had this super Clausius Clapeyron result, which is relatively unusual and not well explained off the top of our heads. I had thought that an increase in wind speeds that we saw was the culprit, and that was causing more uplifting on the Front Range. Pardeep did not believe that, and he was right and I was wrong. And in fact, he figured out that it was an increase in convection, and that was causing the increase in winds. So the increase in precipitation caused the increase in winds, not the increase in winds caused the increase in precipitation. And that took us a year. Now, every event's not going to be that difficult. Some might be more. And so I think it would take, maybe 4 days to do it, but it's going to take somewhat longer to make a statement that you're comfortable with.
Curiosity killed the cat.
Yeah. I would have done it quickly, but Pardeep was more careful.
Flooding, we'll start with Michael. You gave a very specific example, but if we think very broadly about flooding events, whether they're rain dominated or otherwise, would you agree that we generally have good enough data to characterize them, that for modeling them appropriately, you'd need a high resolution atmospheric model, and that the challenge, as you just said, the main challenge is interpretation?
Yeah, I think the data's reasonably good, especially in the United States, maybe not elsewhere. But I think we also need to draw a distinction between relatively brief events like the Colorado event and longer-term seasonal flooding. And for the major rivers, like the Ohio or Mississippi or something.
So those will be those will be snow-dominant floods.
Possibly, or combinations of rain on snow, causing early melting and things of that nature. But coarser resolution models may be, CMIP 5 class models might, I think, are in fact informative for such problems.
Okay.
Because it's a seasonal thing that you want to get at instead of a very intense particular storm.
We had a bit of dark humor in our group, most of which won't be reported. There won't be any heavy breathing. There's one point here is, so to start it off, we considered a lot of the context of what our discussion was in, and we didn't have answers to these points, but we thought they were questions that are useful for kind of thinking, for helping the discussion. One of them is, who is the target audience? That's very unclear, I think, for a number of purposes, especially in a sense of real-time setting. And it also affects which framework, method, and data are appropriate for what you're looking at. The framework and method also depend on the nature of the event and nature of the impacts. So this kind of depends, say, if you're looking in a sort of risk management, if that's your kind of audience. Common extremes, you might think the probability sort of approach might be more appropriate. If you're thinking of black swans, the sort of event that you never kind of considered happening, maybe in that case it's more of a magnitude based, or could this, what's needed to make this event might be more appropriate. Black elephants, which is Tom introduced. I don't think anyone else in the room had heard that term before. So we did manage to get black into this. And those are events where, so black swans are events that you wouldn't have, that you didn't predict, you didn't think they could happen. Black elephants are ones where you should have known that they'd happen, but you were ignoring the information. And then there are issues with fat tails as well, and these affect perhaps the most appropriate way to go about looking at these sort of things. There's a question of transferability of conclusions. So is a result an assessment for one location applicable to a neighboring location, or time of the year? Is it an assessment for a certain process? Would that be relevant actually in terms of the overall impact? So you might have an assessment for hurricanes, but in a certain location, your extreme rainfall might be generated in some cases by hurricanes, in some cases by monsoon processes, say. And finally, when do you stop calling exceedance of a threshold extreme? So at some point in the future, supposedly we're going to be getting to the case where a cold event that happens was fully attributable to emissions as being hot. It could, we wouldn't have been able to have a cold event so hot without anthropogenic emissions. So, at what point do you start changing your baseline? So we broadly, we did have a little discussion about the first topic in terms of uncertainties. Basically, we didn't come up with anything that was, I'm going to say, worth summarizing here. It was well, trying to find something that's a metric for evaluation that we understand as being relevant for attribution is something that's still not quite clear. In terms of bullet 2, framing of questions, so we kind of had 3 sample questions that we could think of asking that might help in terms of this. The first is, to what extent did anthropogenic climate change impact the characteristics of an event? The second one was, could the particular event have occurred as it did without anthropogenic climate change? And so these first 2 questions are essentially the same, but they're taking different lines of approach. One's kind of in the negative, one's in the positive. And does that affect the way you go about doing things then? Finally, how will anthropogenic climate change alter the nature of high impact events through superpositioning of different types of extremes? In this case, we're starting to think of risk. I think in my view there, we didn't italicize it, but high impact is a rather key term there, which starts dealing with issues of exposure. Then in terms of the third bullet on operational attribution, we recognize that operationally there's a balance between robustness, timelessness, and chance. So you can make a robust assessment in advance of an event that has not yet happened, and you could be really lucky and it ends up happening, and then you have a really robust assessment and it's before real time. Or you could do something more broad, and there's a question of whether that's really in detail, but it's kind of a broad class of events. So how relevant is that to yours? That comes back to the transferability of results. And an analogy here that was quite interesting, we thought, and has made us think more, and I'm not too sure of the exact implications, but is the analogy of a prefab house versus a custom house. And so, what are the implications of having prefab houses versus custom houses for what people want or need? There's an issue of the reception of a near real-time assessment. Would a rapid assessment be trusted? Would it depend who it came from? If it comes from a bunch of guys in Africa, if it comes from NOAA. We also noticed that weather forecasting was once tricky, but it's now trusted. So does this mean that we should kind of just go ahead with it anyway, and that means that we learn and develop, and eventually one day it will be accurate? And finally, yes, it is finally, what is near real time? There's kind of been this 5-day, within 5 days of the event kind of thrown out there. which would certainly apply for a flash flood. But if you're in California right now, a 3-year study, which, you know, is kind of, for those of us on soft money, that's the sort of time frame you can maybe expect for a funded project. If you started it 1 year into the flood, we're still, or if 1 year into the drought, we're still in the drought now, your study is real time and it's detailed. So it's targeted, it's in depth, and it took a long time to do, but it's still real time. So where's the threshold between real time and kind of more in this traditional scientific setting? Did I cover everything? Black group?